The origin of Earth's water has long been one of the most intriguing and debated topics in science. For centuries, scientists have sought to understand how the planet became covered in vast oceans, rivers, and lakes that are essential for life. Water is the foundation of life as we know it, and its presence on Earth is fundamental to the planet's ability to support life. Yet despite the importance of water, its origins remain shrouded in mystery. The question of where Earth's water came from is not just a matter of curiosity, but also one with profound implications for our understanding of the planet's history, its geological processes, and even the possibility of life elsewhere in the universe. For years, there have been several theories about the origins of Earth's water, ranging from the idea that water was delivered by comets to the suggestion that water may have formed on Earth itself during its early history. Recent advancements in scientific research have brought new answers and possibilities to the table, reshaping our understanding of Earth's water and how it came to be. The early Earth, a hot, dry world. To understand where Earth's water came from, we must first look back at the planet's early history. Over 4.5 billion years ago, Earth formed from the swirling dust and gas left over from the formation of the Sunday. In its early years, Earth was an extremely hostile environment, with temperatures far too high to allow for the existence of liquid water. Instead, the planet was dominated by volcanic activity, a harsh atmosphere, and a molten surface. This early period, known as the Hadean Eon, was a time when the Earth was still cooling and stabilizing. The conditions were inhospitable to life, and the water we know today had not yet come into existence in liquid form. The question then becomes, how did Earth transition from a dry, molten world to the blue planet we see today, covered in oceans? For years, scientists speculated that the water on Earth came from one of two sources. It was either present from the very beginning, or it was brought to Earth later on through some external process. To answer this question, scientists have turned to several different fields of research, including geology, astronomy, and chemistry. Theories about the origin of water on Earth. There are two major hypotheses about where Earth's water came from: in situ formation and extraterrestrial delivery. Both theories have been the subject of intense scientific investigation, and recent advancements are shedding new light on both possibilities. In situ formation. Water from Earth's early history. The first theory, in situ formation, suggests that Earth's water was always present, forming as part of the planet's early chemical processes. According to this theory, as Earth cooled from its molten state, the gases in the atmosphere, including hydrogen and oxygen, reacted chemically to form water. This process, known as hydrothermal outgassing, could have been responsible for releasing water vapor into the early atmosphere. Over time, as Earth cooled further, this water vapor would have condensed into liquid form and eventually pooled into the oceans. One important clue supporting this hypothesis comes from Earth's mantle. Recent research has found that water is deeply embedded within the minerals of the Earth's mantle. Some scientists believe that this water could have been trapped in the minerals as the planet formed. Over millions of years, this water could have been released through volcanic activity, eventually making its way to the surface. This theory suggests that Earth's water may have formed on the planet itself, without the need for an external source. Extraterrestrial delivery. Water from space. The second theory is that Earth's water was delivered from external sources, most commonly comets and asteroids. According to this hypothesis, during the early years of the solar system, when Earth was still in its formative stages, icy comets and water-rich asteroids may have collided with Earth, depositing water onto the surface. This theory is supported by the fact that comets and asteroids are known to contain water in the form of ice. In fact, many comets are made up of a mixture of rock, dust, and frozen water, and their orbits often bring them close to Earth. It is thought that during the late heavy bombardment, a period of intense asteroid and comet activity around 4 billion years ago, these bodies could have bombarded Earth with large amounts of water, contributing to the formation of oceans. Recent studies have shown that isotopes of hydrogen, such as deuterium found in Earth's water, are similar to those found in certain types of comets. This has led scientists to suggest that comets may have been the primary source of Earth's water. One of the most famous pieces of evidence supporting this idea came from the Rosetta mission, which studied the comet 67P Churyumov-Gerasimenko. The mission revealed that this comet contained a high amount of water with an isotopic composition similar to that of Earth's oceans, further strengthening the theory that water may have been delivered to Earth by comets in its early history. The modern synthesis, a combination of both theories. While the two theories, in situ formation and extraterrestrial delivery, are often seen as competing explanations, recent research suggests that both processes may have contributed to the origin of Earth's water. It is likely that a combination of local formation and extraterrestrial delivery played a role in shaping the planet's water-rich environment. One recent study proposed that Earth's water could have been formed in the planet's early atmosphere through volcanic outgassing. while comets and asteroids contributed additional water over time. This dual approach suggests that the Earth may have had a small amount of water from the outset, which was then supplemented by water from space delivered by celestial bodies during the late heavy bombardment period. Recent studies of water on other planets and moons in our solar system also support this combined theory. For instance, Mars, a planet with a past that mirrors Earth's in many ways, shows evidence of water having existed on its surface, but it also shows signs of having undergone intense volcanic activity. Similarly, moons like Europa, Enceladus, and Titan have subsurface oceans, suggesting that water may have been a more widespread phenomenon in the solar system than previously thought. The role of water in supporting life. The presence of water on Earth is not just important for the planet's geologic history, but also for the existence of life itself. Water is often called the universal solvent because of its ability to dissolve a wide range of substances, making it a crucial component for biochemical reactions. From the formation of proteins and nucleic acids to the basic function of cell membranes, water is essential for life at the molecular level. The search for extraterrestrial life also ties back to the origin of Earth's water. Scientists are increasingly looking to other planets and moons in the solar system to understand if life could have originated elsewhere, particularly in environments with water. For instance, the discovery of water vapor on Venus and the possibility of liquid water beneath the icy crusts of moons like Europa and Enceladus have made these places prime candidates in the hunt for alien life. New discoveries and future questions as technology advances. New methods of studying Earth's water and the origins of liquid water in the solar system are emerging. Advances in satellite imaging, space probes, and laboratory techniques are allowing scientists to probe deeper into the history of our planet and the history of water in the universe. These findings are crucial not only for understanding Earth's past, but also for uncovering the broader mysteries of the solar system and the universe. For instance, Mars rovers like Curiosity and Perseverance are investigating the presence of water on Mars, both in its past and potential subsurface lakes today. Data from the James Webb Space Telescope and other observatories will continue to provide insights into how water is distributed throughout the galaxy, and whether planets around other stars could host the right conditions for life. Additionally, Earth's water cycle itself offers ongoing mysteries. For instance, scientists are continually studying the deep water cycle, how water interacts with the planet's crust, and the role of subsurface reservoirs in maintaining the Earth's freshwater systems. There is growing interest in the possibility that some of Earth's water could be much older than previously thought, locked deep within the planet's mantle, suggesting that our planet may have had water even in its earliest stages. Conclusion. The continuing mystery of Earth's water. In conclusion, the origin of Earth's water remains one of the great scientific questions of our time, but the most recent research is shedding new light on this fascinating mystery. Earth's water likely has both local origins from the planet's early volcanic activity and extraterrestrial contributions from comets and asteroids. Together, these processes form the conditions that allowed Earth to develop into the water-rich planet capable of supporting life. As scientists continue to investigate the origin of Earth's water and the broader presence of water throughout the cosmos, new questions will arise about the possibility of life on other planets, the role of water in planetary formation, and how water continues to shape the geological and biological history of Earth. The study of water's origins not only provides insight into our planet's past, but also offers valuable clues to the broader questions of life beyond Earth. Whether in the depths of the oceans or in the ice-covered moons of distant planets, water remains the key to understanding the fundamental forces that govern our world and the universe at large.